Hello. Hope everybody can hear me. Hello and welcome to today's webinar called Regional Multifamily Electrification Retrofit Planning, a Case Study. This will be presented by Reese Davis. Today's session will be recorded and available through the ibpsa-usa YouTube channel. If you have any issues hearing the presentation, please try calling in by phone instead of using the computer audio. This is a Zoom webinar, so you will be muted and off camera during the session, but please feel free to participate by posting questions in the Q&A tab at the bottom of your screen and by entering any comments into the chat. By default, the chat is set to send to just the presenters, so be sure to click the down arrow next to the chat and select all panelists and attendees if you would like everyone to see. We welcome your questions, thoughts, and ideas as we continue to work towards ibpsa-usa's mission of fostering better buildings through simulation. Reese Davis is a technical consultant for Resource Refocus, a small firm located in Oakland, California, that performs modeling, analysis, and development of building energy and climate policies and programs. He is currently leading the development and analysis of the residential New York energy building codes that move the state toward a clean, healthy, and decarbonized built environment. Prior to his work at Resource Refocus, Reese worked with SMUD's building electrification and energy efficiency team on electrification planning, electrification load planning and forecasting while pursuing his master's in energy systems at UC Davis. He has his bachelor's in mechanical engineering from Ohio State University. Please join me in giving a warm welcome to Reese Davis.
Thanks, Natalie. I'll just jump right in after that intro. So hi, everybody. I'm Reese. I'm going to be talking about the barriers and opportunities for multifamily electrification retrofits. I guess just to preface and introduce this research, this was research that was performed a couple years ago, started out a couple years ago with the Sacramento Municipal Utility District to look at the impacts of basically total electrification of multifamily buildings. And I think that along with the results of this research, what's interesting to discuss about it is how in the last 2 years, additional kind of methods and data sources have come online to do this kind of work, because I do think it is an important kind of process for all utilities and local governments to be able to undertake. So I kind of encourage you to think as we're walking through this about ways that we could improve this work and kind of be able to transfer it to other territories. So with that in mind, I will jump right in. This is my BPSA slide. I can come back to it if there's any questions about it. But just jumping in, so why focus on multifamily electrification? I think more than any other building sector, the multifamily building sector has the biggest variety of building types, anything from a duplex to a high-rise apartment building that's mixed use. There's issues of split incentives. So, owners are incentivized to kind of save money on upgrades and not necessarily invest in energy efficiency. And obviously tenants are the ones who kind of deal with the consequences of those decisions too, or to not upgrade a building to more efficient or electric systems. And then there's also in many multifamily buildings, the issue of central water heating, which compared to other kind of electrification retrofits is not an easy just swap out. Not that any are necessarily that easy, but this requires a kind of an additional degree of planning, and there's some physical constraints. So I think it's an interesting area to look at because I think that utilities have a role to play, utilities and local governments have a role to play to assist building owners with these these retrofits. I think it has a big part to play in terms of equitable decarbonization. Just because of those split incentive issues, I think giving renters access to the benefits of electrification without, unduly burdening them with increased bills or pricing them out of apartments that do get electrified is a pretty critical thing to talk about when we talk about multifamily electrification. So looking at Sacramento County, it's mostly urban and suburban, all of Sacramento Municipal Utility District, or SMUD's territory. It's in climate zone 3B. It's pretty hot in the summers. It's generally the peak is driven by cooling loads in the summer. There's over 110,000 multifamily meters in around 6,700 buildings. I think what's interesting is you can see on the right, the majority of buildings are 24 units or less. So they're mostly low rise. There aren't a ton of, high rise apartment buildings in Sacramento. And, while I think this misses out on some of the challenges faced by giant cities like New York, Chicago, and San Francisco to some degree, it's a pretty good representation of a pretty standard mid-sized city across the US. So I think there's a lot to take away from Sacramento as a case study. We had anonymous SMUD meter data that was available, so that's what we used to kind of perform the study. And I'll get into other data sources that we used. But basically, as I said, our goal is just basically to look at the impacts of electrifying every multifamily unit in the county. This is SMUD's territory. And these impacts obviously include financial, both upfront costs and ongoing costs, and carbon savings, but also the impacts to the grid infrastructure and electrical infrastructure like building panels is going to be a big part of these retrofits. And so we want to look at that. We also just have the ability to look pretty granularly at the location of these retrofits and where the impacts are greatest for costs and electrical infrastructure, and also from an equity perspective, where are the benefits for lower income communities and disadvantaged communities. So getting into the methodology, the first thing we need to know is what these buildings have in terms of fuel types. So we need to know if they have gas heating or space heat or water heating to know whether we need to electrify them. And that's kind of easier said than done to do for every unit in the city. So using resources such as building permit data from the county assessor, needs assessments from the tax credit allocation committee, which is the kind of a California authority that dictates government subsidized housing, and it basically requires these capital needs assessments, so we can kind of mine data from that. And then we did have some anonymized data from a SMUD program contractor that we could kind of use as a guide, but not necessarily as a matching unit to appliance. So after we did all that, we were able to basically match the fuel type for a small percentage of appliances. And I do want to just stop here and say that we're not getting as granular maybe as I would like, and this is kind of a future work thing, but I would love to be able to look at different kinds of space heating, like, mini split, upgrading with a mini split versus like a ducted multi-zone space heating system, different kinds of water heaters. We do differentiate between central and unitary, but that's kind of the lowest level of granularity that we're able to get. We're also just not really able to look at, we're barely able to look at cooking appliances, but looking at laundry and pools is a little more challenging, and just because that data isn't really available anywhere that I was able to find. So that is kind of an area of outstanding work. But just looking at what we were able to match up to start with, we basically are able to know 17% of the heating fuels for space heating and 21% of the fuels for water heating, and we're going to need to predict the rest. So using the meter data for the buildings that we do know the fuel and system types. So like for all the buildings that we know have electric space heating and central gas water heating, we're able to create a load shape that's normalized by annual energy use and just averaged across all the buildings. We're able to use these for each of those combinations of fuel and system type to match with the buildings with unknown fuel type. Using just a minimizing of sum of squared errors algorithm. So we're able to match most of these load shapes up and kind of predict what kind of space heating and water heating they have. Cooking does not really show up in load shapes in the same way. And so it's hard to predict from load shapes. So for cooking fuel type and also for buildings that had outlier load shapes that didn't really meet a threshold of matching from the minimizing of squared errors, we had to use multiple imputation by chained equation method. So it's just a kind of predictive algorithm that had to be used based on like building attributes such as year built, zip code, building size. We are able to kind of, predict the cooking fuels and for those outlier fuels, outlier buildings, that their fuel type, just to look at what those normalized load shapes are for the buildings that we do know the fuels for. On the left, you can see a load shape for all the buildings with electric space heat and central gas water heating. And then on the right, there's a gas space heating with central gas water heating. And just to point out that, you can see in this graph that just a higher percentage of their annual electricity use for the electric space heating buildings is used in winter heating hours. So, I mean, that is intuitive, but just visually, I think, shows like how we were able to match up these buildings. So buildings that had load shapes that looked more like the one on the left than the one on the right, we basically, that's how we predicted these fuel types. So after doing all that, kind of the takeaway is that 60% of space heating, this is by unit now, 60% of space heating is done with gas, 88% is done of water heating is done with gas. And in terms of central versus individual, 90% of space heating, 90% of units have gas space or individual space heating, apologies, and 71% of water heating is done individually as opposed to central. We do kind of end up treating central and individual space heating pretty similarly in terms of electrification load shapes. And then for water heating, we do break it out by central and individual because the load shapes of the electrification retrofits tend to look different, and I'll get more into that. And for cooking, 58% of cooking is done with gas currently in multifamily units. I'm just looking at the question, and I think I answered it, but happy to go back and answer that more later. So as I said, we want to take the meter data we have available and basically electrify all of the fossil fuel end uses. So this basically requires us to take kind of a predicted electrification retrofit load shape and add it on to the meter data that we have, an 8760 load shape. This is obviously going to be kind of overly generalized. Every retrofit's going to look different, but we had some base load shapes that I'll show on the next slide, and we were able to scale them based on our analysis of each building's like heating and cooling and water heating use, just that we estimated based on temperature dependent kind of normalization. So here are the base load shapes that we ended up skewing for each unit. I think the biggest things I want to focus on here, the air source heat pump, which is basically the HVAC electrification measure. You can see that there's a negative load shape in the summer, or negative load in the summer. That is based on two assumptions. One, that every unit in Sacramento has air conditioning. Now, based on appliance saturation surveys that we've looked at and just kind of general anecdotal, I've lived in that area. It's really hot, and it has always been really hot. It is a fair assumption that almost every unit has air conditioning. And so the next assumption is that the air conditioner that you're replacing when you replace the furnace with a heat pump is going to be less efficient than the heat pump that's going in. So you're getting energy savings in the summer from that heat pump going in and replacing an air conditioner. That's not going to be true in every climate zone or every city, but it just so happens that it's pretty much true across the board in Sacramento. And then I'll just point out that the difference between the central heat pump water heater and the unitary heat pump water heater, they do have different load shapes, just based on the way that they operate. And I'll just note that this data comes from a combination of sources, some from the SMUD program, like efficiency programs and their estimation of these measures, and some from the CBEC RES, the California code modeling software. I think if I could do this again, and if I do kind of rework this, I would look more at places like ResStock, the NREL's kind of residential load shape library. I think there's a lot more of this information that's coming online, which is really helpful. So I think there's future work there, is what I'll say. Getting into the panel and transformer impacts, I think the biggest risk for electrification projects, kind of one of the big hard barriers, is the potential need to upsize a panel or a transformer. And so we need to know what sizes these things are to know if we're going to need to upsize them based on the kind of rolled up building loads and transformer loads. So we were able to get transformer sizes from SMUD for every transformer that was connected to a multifamily building. Building panel sizes are not really available, as information. And so we had to kind of reverse engineer the building size based on transformer voltage, transformer size. This is what SMUD uses to size their transformers, basically. So we were able to kind of reverse engineer that for each building. And even more kind of unknown is the unit subpanel size. We wanted to look at, for buildings that had kind of panels at the unit level, what size are those? Really the best practice that we could find based on interviews with SMUD's multifamily program operators and other folks is that vintage is probably the best indicator. So if we know the year that the building's built, we can kind of estimate a unit panel size. If not, we have to kind of go by main service size, the main building panel. And we did add kind of an additional capacity if there was an in-unit electric water heater. I won't spend too much time on this, but just showing you that basically on the number of building panels, the most common size of building panels were 200 amps and 400 amps at the main building level, just because, again, there's a lot of those small low-rise multifamily buildings. But and then the number of units by panel size, again, is pretty much a function of vintage. So most multifamily buildings in SMUD territory were built before like 1980, and that's why you see 40 amp, 60 amp unit panel sizes. And then the costs, again, there's a lot of text on this slide, but I just kind of want to show you that they're based on SMUD planning materials. We kind of able to get a rough linear assumption for what the cost of transformers is by size, by kVA. We also added an additional cost on if they had something called direct buried distribution lines. This is a practice that was common at some point, where there were buried kind of underground distribution lines that were just buried in dirt and that need to be trenched to replace, and that costs extra money. So we added kind of an additional cost to those buildings. And we just based on interviews with SMUD's multifamily program contractor and some electricians, we kind of got a service panel and sub panel sizing cost estimate for when they need to be upsized. And then for upfront project costs, I want to caveat this with, there's a lot of discussion around what the cost of electrification is, and project by project, these things change. It's pretty much impossible to estimate what a project cost is going to be beforehand. especially at this scale. But these costs come from a couple different sources, but just, Title 24, supporting analysis, and some other SMUD program resources. These are our best guesses for kind of base costs for these things, and some are different per unit by size of building. But I'll just say that we did scale them similarly to the way that we scaled the electrification load shapes, just like based on like the amount of, if a unit seemed to use a lot more of their energy for heating and cooling, we assume they had kind of a larger size system. So we maybe scaled up the cost of their heat pump. And I will also say that we wanted to look at the costs compared to replacement gas system. So, at burnout of, like, let's say a furnace, if you choose to replace that with a heat pump compared to just replacing it with the business as usual case of furnace and split system air conditioner, what's that cost? So getting into the results, and these are location specific. I'll say that these are specific to SMUD territory. I don't think it's fair to say that they would transfer to every mid-sized city in America. But I think there's interesting lessons that can be applied. And the biggest takeaway really is that there are certainly some transformers and panels that are undersized currently and are kind of overloaded currently and probably in line to be replaced. But there's very few systems that when you add on these electrification retrofits that get additionally overloaded when looking at an annual peaking situation. So for example, for transformers, 8.7% of all these transformers that are connected to multifamily buildings are currently overloaded, as defined by spending an hour above their nameplate rating kVA in a given year. If you add on electrification, there's only a 0.1% increase in that number. So very few. Similarly, building panel loading, an overloaded building panel is defined as going over 80% of their nameplate rating for using, I believe it's a 15-minute period in 12 months, but we only had hourly data available to us. But you can see that there are a good number of building panels that are overloaded. Again, there's uncertainty in this because of the estimation used on the building panel sizes, but an additional 1.5% of these building panels are going to be overloaded because of electrification. Similar case with sub panels, just an additional 0.2% overloaded because of electrification. So really, I think the takeaway here is, at least in SMUD territory, there's not a huge concern of a bunch of electrical infrastructure needing to be upsized. It's more case by case. A big reason for that is that summer peaking grid. When you already have a high peak because of air conditioner use in the summer, if you're replacing that system with a heat pump that's more efficient, and you assume that every multifamily unit has an air conditioner, which we talked about, you're not going to really see an increase in that peak load, even if you're replacing the water heater with an electric water heater or the stove with an electric stove. It just is less likely than you might see in a different climate. Looking at project costs, so upfront costs, the way that these are split out is basically by kind of groups. So the left bar is the proposed electrification project cost, and the right bar is like kind of business as usual gas replacement cost. And you'll see that there's their group. So on the leftmost group is basically buildings that need a panel or transformer upgrade. And so that dark blue is the infrastructure cost per unit. And that definitely, makes the project a little less savory for building owners. And so anything you can do to avoid those upgrades is definitely going to help the project go. But I've also included the incentives that were available at the time of this research from SMUD. And I think one caveat with incentives is they change a lot. And I think that's one of the problems with incentives is it's hard to know exactly what's available from different sources. Now with IRA funding and with California state level electrification funding, that these have changed and actually probably increased. But I don't necessarily want to present it as like, oh, incentives will take care of any of the differences in costs of these projects, because that's not necessarily how building owners calculate things. So I've included them there, but just want to caveat that. Looking at bill impacts, I'm just looking at a question in the chat. What cooling efficiencies did you assume for the new air source heat pump equipment versus the old equipment that it's replacing? Yeah. I can't remember the specific kind of SEER rating for the old air conditioning equipment, but I think we assumed like, you know, the minimum standard efficiency for buildings for I think like, you know, 2005 kind of air conditioning, just assuming that it's at the end of its life, you know, 15 years later. And I can't remember specifically what that SEER is. And the heat pump going in, I think, was like a minimum efficiency, minimum efficiency heat pump. So, and again, at that time, I think, I can't remember if like 14.5 SEER is the air conditioner going in, but I can look into that. But anyways, the impacts of the bills are pretty much, I will say that these are, again, SMUD specific. SMUD has some of the lowest electric rates in California, and that's a big reason that these results look the way they do. But basically on the left-hand side is the current bill breakdown, electric and light blue, gas bills in dark blue. Gas bills are an estimation. We don't actually have their gas bills, but and green is after electrification, our estimation of what their bills will be. And there's just pretty much savings across the board, depending on what you're replacing. Like if you're replacing both water heating and HVAC and cooking, or just one of those. And I think the most important thing to note is on the right, if you are a low income customer, kind of the benefits you see are even greater as a percentage of your bill. If you have all gas appliances and you retrofit them, just the way that the SMUD low income rate works compared to the PG&E gas care low income rate works, you can see $100 per year in annual utility bill savings, which can be pretty significant. And just to highlight this, the average customer in these retrofits will see an 11% bill savings, but customers on low income rates see 26% savings. Customers in government subsidized housing see 25% on average, and customers in disadvantaged communities will see an 18% bill savings on average. And so kind of the last thing we looked at, and this is kind of a SMUD specific request, is where should we start reaching out to folks and kind of targeting these retrofits so we can start, you know, holding the hands of the building owners along the way, because these can be trickier retrofits than just a single family homeowner. And, you know, I think with a lens on equity, they wanted to kind of look at, you know, investing in historically underinvested communities and disadvantaged communities. They wanted to, you know, do the low hanging fruit of areas without, you know, overloaded transformers, and just generally avoiding big project hard barriers. And so, you know, I won't get into all of these, but these are kind of the 6 categories I thought of as I was kind of looking at a quote unquote targeting score for census tracts. I think one interesting thing is in the density and timing score. In government subsidized housing, every 20 years they have to think about re-syndication to kind of keep getting the tax credits. So that's a great time to intervene with electrification upgrades. And so just you can look at the time since the last re-syndication period to kind of target those. But there's, you know, other ways to target in terms of equity, in terms of the, you know, electrical infrastructure and bill savings. I won't kind of go into these except just say that, you know, depending on what you're focusing on, you can kind of look into these different census tracts and say, like, let's look at some multifamily buildings here and see where we can do the most for what we want to do to kind of achieve our electrification and equity goals. And one more caveat is that hot water storage is going to be an issue for some buildings in particular, especially for central heat pump water heater systems. As the chart shows below, central gas boilers in these big high-rise buildings need about 55 square feet of space to kind of for the storage needed to provide the load for that building. Whereas central heat pump water heaters, to really operate the way that they work best, they need much more than that, around 318 square feet for an 89 unit building. And that space difference can really cause problems, because you're talking about maybe a small mechanical room that was only designed to, hold a gas boiler of that 55 square feet. And now you're talking about adding on, a portion of an apartment basically. And that might just not be available. So in some cases, this can really just be a hard barrier where you need to think of a different solution, or the costs are going to skyrocket. And so in these cases, I think, these are the kinds of things that it's helpful to think about before you go in and do, just like say, I'd like to retrofit this building. I think picking out the low-hanging fruit, electrifying where it's low cost, benefits all around to start with, is a good way to do it while balancing those equity concerns. I don't think it really helps anybody to start with the most expensive retrofits. So just in conclusion, I think, I think what this shows on a region-specific level is that replacing fossil fuel equipment on burnout in these multifamily units is just financially feasible, like right now. Bills are going to decrease for most tenants. Costs are not, exorbitant unless you hit some of those hard barriers. And I think specifically, there's ways that utilities like SMUD can help building owners, plan in advance. They can set up customized plans based on electrical infrastructure sizing for these multifamily buildings, and being ready to electrify when a boiler goes out, or when you've got some upgrades going to happen. Like there's ways to intervene in advance. And I think an important thing to note here is, I think there's a role that governments need to play in protecting disadvantaged tenants when these retrofits happen, because again, there are sometimes increased costs associated with electrification retrofits. And I think the worst case scenario is for tenants to be displaced because of price increases and rent increases due to electrification retrofits, and then pushed into buildings that have gas infrastructure. And if we keep doing that and kind of pushing folks who can't afford to live in these electrified units into these gas buildings, we're going to see those impacts just kind of compact and compound. And that really would be a nightmare for equity issues. So I think that's something worth thinking about. I mean, I know this is a modeling workshop, but I think that's the reason we use modeling, is to understand those impacts. And just to talk about some future work here, and I think I harped on some of these, but it would be really, I would love to go back and update this with more granular, more load shapes that were developed with more kind of level of scrutiny. So ResStock and Comstock have really come out with interesting electrification load shapes based on both meter data from pretty specific region, like regional data, and also from building modeling, thousands and thousands, maybe more than thousands of building models that they've run. And so I think that would be a really interesting thing to look at, and looking at different systems, outside of just a, generic heat pump, like looking at, mini splits or package terminal heat pumps, ground source heat pumps, even also adding additional efficiency measures and looking at how that affects the peak load. Another thing that would be helpful to look at is, the way I was looking at the building panel overloading was based on the kind of, 8760 approach of looking at meter data. But I think what really the most prominent way to determine kind of electrification or electrical panel loading is using this deemed load calculation, where you basically look at the size of equipment that you're putting in and whether it kind of goes over some threshold. And I think it's important to, even though we know that some of these building panels can handle a heat pump, the calculations may not come out with that same assumption. And I think it's important to understand where those clashes come through. So doing this kind of modeling again with that deemed load calculation in mind would be interesting, I think. Something that, you know, this data I use, I should have prefaced this data is from 2019, because we did want to avoid the impacts of COVID. I think it's clear that there are probably some ways that electric loads are changing and not going to go back to pre-COVID use profiles. So I think it would be important to look at that. And then I think weather normalizing and looking at the potential impacts of a changing climate. You know, Sacramento is going to get hotter. That's going to have impacts on peak loads in different ways. And so, I mean, it's going to get hotter. I think there's also more nuanced ways that the climate's going to change locally. So just looking at that would be interesting to understand the future needs of kind of electrical infrastructure for SMUD. I think that's about it for me. You know, I'd love to talk about kind of ways that this methodology can be updated or kind of transferred to different utilities and cities and other kind of planning levels, because I do think it's important to plan for these kind of electrification upgrades, and also like different building types. I know I'm looking at multifamily here, but obviously you're going to want to do a system-wide planning process if you're a utility. But yeah, so that's it for the presentation, but happy to stick around. And I think I got all the questions that I can see in the Q&A, but happy to answer any more.
Thank you, Reese. I'm also kind of curious if any studies similar to this look at the, you know, panel upgrades accommodating electric vehicle charging.
Yeah, that actually was kind of a side quest that I went on. The problem at that time was I just didn't have, I think, the information on charging profiles that I needed. And I think there a lot more data has come out recently about how people use charging, because it depends on the location, and multifamily charging is different than single family. So I would like that to be added. I don't know that I've seen a specific study like adding that on to this kind of panel loading study, but it definitely would have an impact. And in some cases, just when EV infrastructure gets added, they just replace the panel no matter what, just because of the predicted load. But I think it's possible to use kind of different strategies like load splitters, or kind of managed charging to avoid an infrastructure upgrade. So I think that there's an interesting add-on to the study for EVSE for sure.
Very cool. Well, if any of our attendees have further questions, please let Reese know. Otherwise, we can wrap things up a bit early.
I can hang out in awkward silence for a few minutes. I have no problem doing that.
I think you've answered all of my questions and hopefully everybody else's.
Awesome.
So I will thank you, Reese, and thank you everyone for joining us today. For those of you watching us on YouTube, please like the video and subscribe to our YouTube channel. If you would like to follow up with us, please feel free to reach out at admin@ibpsa-usa. Thank you all and have a wonderful rest of your day. Thanks, Henry.